Hello, I'm Victoria Smali. I'm from Kiev. I work in National University of Life and Environmental Science of Ukraine. Sergei Sayapin can be present since he is engaged in assembly and adjustment of drones in territorial defense forces.
Hello, I'm Nathan Smolny, Technical University of Ukraine Igor Sikorsky Kyiv Polytechnic Institute, vice student.
um, Search and classification of objects in zone of reservoirs and coastal zones. This presentation was made by Victoria Smali, Nathan Smali, Sergei Sayapin, and covers main parts of article search is classification of object in zone of reservoirs and coastal zones. In the modern world of robotics, many tasks require the intervention of artificial intelligence to increase the number of tasks to be solved, increase productivity, reduce execution time, scale processing, exclude a person from the processes of performing routine tasks, and ensure online information collection and processing routines. So, for example, creating maps and patrolling water bodies using traditional methods is a time consuming process that can be improved and accelerated with the help of artificial intelligence. In the modern period of development of unmanned aerial vehicles comes the realization that many tasks of research and observation can be transferred to automated drones, which will perform them faster and better due to the possibility of installing additional computing power as a payload. The subsystem will control the drone, which must move along the route at the point specified by the user and be able to detect such objects as boat, ships, buoys, garbage, islands, swimmers, and drowning people from the image from the camera. It was decided to use Ontalytic API combined with RubberFlow interfaces of data manipulation in order to set up the best possible working environment. Ontalytic's API provide well-documented train test environment with a lot of available model classes such as YOLO, SUM, YOLO-NA, T-Data.
This slide tells us about data distribution. The largest number of markings belongs to the boat class, 1629 units. Along with this class, the following classes are well represented in descending order: swimmer, boat, and buoy, respectively 1498, 1270, and 1186 units. The garbage and drowning man classes contain the least number of images, which can lead to training anomalies. The distribution of images between datasets is shown on the slide. On this slide, you can see a model comparison performed by developers as well as our test results. According to the obtained results, we can see that the system detects objects on the water surface, but the classification of these objects is not that good. There are several reasons for this: errors in the leveling of the dataset, the small size of the dataset, and data source being not a drone but boat on the sea, so data source is not related to our targeted data source. On this slide, you can see the results of testing without classification function and lowered accuracy threshold. due to models having a high probability of recognizing the objects bought and shipped, but assign the recognized object to the wrong class, so misclassification problem takes place. Garbage objects were not recognized, but the bought object was completely ignored. So the lowering of accuracy threshold allowed us to get depicted results and so achieve desired output. Probability of finding objects on water surface is high, as well as probability of classifying water surface as any type of objects being low. A possible scenario of using the built model is the general collection of information about the reservoir without regard to the classification output. In the process of such exploration, I consider it expedient to collect a dataset that will correspond to the data from the drone. The data of the current dataset is data from surveillance cameras and video recordings from boats, as it was mentioned. In the future, form the dataset according to the developer requirements, applying the necessary data augmentation steps. And on this slide, you can see used sources.